are in listen-only mode.
Hi everybody, this is James from Apteco. It's spot on 11 o'clock in the UK, midday in Europe, 8 p.m. in Australia. And I think we've got guests from all those time zones. So thank you for joining us. We are going to spend an hour together looking at the new behavioural modelling capabilities in FastStats. I'll be your host. I have two of my colleagues online with me, Mel and Ray, and they are there to help answer any questions that may arise during the session. I'm James Alty, Managing Director of Apteco, and I'll be taking you through some PowerPoint slides and then the software demonstration. Because we have quite a lot of people online, we have started with all your calls muted. Otherwise, we pick up an awful lot of background noise and chatter. But questions are welcome through the GoToWebinar system. If you put in questions through the question mechanism or the chat mechanism, we'll try and handle those during the webinar. Any that we can't do during the session, we will come back to you afterwards. And if we have time, we'll open up the lines for verbal Q&A at the end of the session. We'll see how we do for time. So what is behavioural modelling about, and why are we holding a webinar on it? Well, it's a new mechanism to help you build insights from the transactional data held in your FastStats system. It allows you to use a range of techniques to look at and identify predictive patterns in the transaction data, patterns in your customers' behaviour that you can use to help target your marketing communications. And this webinar aims to introduce that process and show some practical examples, taking you through some examples using our demonstration data in a manner that we haven't been able to do in our regular quarterly release webinars simply because of the time needed. So we're dedicating a whole hour just to this topic. And I hope by the end of today, you'll have a clear understanding of the technique. There are a couple of handouts on the GoToWebinar platform. Those are actually PDFs produced from our knowledge base, and I think they show you great examples of how we document the facilities that we introduce into the Apteco marketing suite. If you've not used the knowledge base before, log on to apteco.com and come and find the help center, and in there you can search the knowledge base and find hundreds of articles like that, although these actually are two of the bigger articles that we have in the knowledge base. So we're going to demonstrate how FastStats can help you uncover patterns that have always been there in your data, patterns that you could manually identify using selection and analysis techniques in the application, but now in a manner that we think will be easier and more effective. You know, every analyst is under time pressure. They've got to produce results. The organization wants to use data as effectively as possible. And so we're going to try and show you how you can do that work really speedily now, how effectively we've built a framework for you to follow your train of thought into the analysis of the patterns around your customers, and show you how you can use that with the established techniques, particularly in this case profiling and PWE scoring, to create results that you can use to maximize your marketing efforts, and learn how these techniques can be applied in a predictive manner to assist in targeting for marketing comms. So let's take some examples. Simple example, lapsing customers. What do they do in the months prior to lapsing? What can we see about that behavior, and what could we do to intervene? And the idea is that if we can see behavior across a series of different touch points, in this case, you know, contact center, in-store, and a review site, and maybe a negative sentiment social post, you know, those behaviors can be identified together to produce a predictive effect that this customer is unhappy and actually we want to do something about it. And we could put in some steps to alleviate that feeling. The interesting point here is that the data is across multiple transaction types, and I'll show you today how easy it is to build behavioral modeling across different transaction data that you might have in your FAST system. Looking on the more positive side, what about people who buy big, who spend high value with us? What can we do to identify those people? Clearly, you may have some geodemographic characteristics of them, but quite likely the primary data you will have on them is the interactions with your brand and the frequency, the value, the patterns of those transactions may be your best chance of spotting those individuals. And if you can use the measures that we can create on those individuals to identify them, to see that they are similar to previous big spenders, then perhaps you can step in to handle that potential VIP earlier. Look after them and nurture them and build a better chance to build business value with them. So clearly, as with all of our technology, you can use your data and these techniques for whatever purpose you wish, but we'll try and show some illustrations. And here's just some further quick examples. So we might be able to see in a travel business that bookings are reducing in frequency over time. We could understand that that is going to cause lapses. Sorry, my keyboard repeated. That's going to cause lapses, and we want to step in to remove that risk so that they don't lapse. We might see that comms have added up. Maybe multiple teams are contacting. Clearly, we have technology that can help you avoid that over communication, but that might cause someone to unsubscribe, and you might wish to avoid that unsubscription. You might see a positive pattern with a donor to a charity, a good supporter, they're not over contacted, they're making donation, and we want to encourage that behavior. And then finally, a slightly more detailed example, perhaps looking at a series of transactions, in this case in the hospitality sector, you might see that somebody is no longer buying a drink with their meal. So here we're looking at the content of the basket rather than just the frequency of the orders. And we're looking at the combination of two of those characteristics. You know, are they buying X and Y together? They used to, but they're not doing it any longer. And so we want to promote that particular product. So that gives you a flavor of how the transaction data spread over time with date and timestamps on it for each individual supporter or customer can be identified, can be used to start building patterns that we can predict from, patterns of behavior. Just to give you an idea, I've mentioned this software in some of the recent software release webinars. It was first introduced in our Q1 release, where we had the basic feature with fixed point in time behavioral modeling, and that's what I'm going to be showing you today. There are improvements to that have been made in each of the subsequent releases, the Q2 and Q3 releases, where we introduced the ability to run sampling, for example, and I'll try and remember to show you how to set that up. In Q3, we introduced combinations. That's the sort of X and Y purchases we just saw on the chart. In Q4, not yet in your hands, but well advanced in development and testing, we have a change which allows us to show event-based point in time, so behavioral modeling. So rather than saying we're measuring everybody from the 1st of January, as I'm going to do in my demo today, we can instead say we're going to measure everybody by the date of that individual's first purchase, for example. It will be a different date for each individual, but we'll look at the patterns relative to that date rather than in terms of a fixed date. And then in Q1 next year, we will continue with further enhancements, particularly looking at the user interface, making it as approachable as possible. This is a technical topic, but we want to make the UI as approachable as possible. And looking at the possibilities to do automated behavioral modeling feature detection. So instead of the analyst driving the process, using the Apteco marketing suite and the power of the servers to find some candidate behavioral modeling features that the analyst could then consider, rather than the analyst driving it with their train of thought, as I will be doing today. And that's our long-term goal, introducing that AI in the Apteco marketing suite so that we can explore for you the behaviors across multiple transaction types and offer you candidate predictive behaviors that you can then use in your campaigning activity. So how's the capability presented in the software? It's a new technique in FastStats introduced in 2020. It operates with the profiling tool, and it is part of the predictor bundle, which is presented in the modeling environment. You'll see me using the modeling environment extensively today, and in fact, it's probably really going to bring the modeling environment to life. It's always been a useful framework, but this gives you a strong function in the modeling environment. To use it, you need multi-table data. There is no behavior detected across a single table. So you need, for example, to have customers and their purchases or web visits or policies or donations or some sort of activity. And that activity may have further detail. So you might have basket content, for example, as well as the purchases that were made. We will use 3 different dates during the demonstration and during the technique. These are the training, the evaluation, and the scoring points in time. So we will be identifying a point in time, some point in the past, where we have recorded customer behavior. We've got that detail in their transaction history, and we're going to use that to try to identify behavioral features that are predictive of the subsequent behavior that we already know they took. So we will be setting some sort of target and measuring it on the historic data. Having created those behavioral features, we will then evaluate them at a different point in time to check that we have not overfitted to the specific case in our training period. We'll look to see if what we've learned from the training period can usefully predict who might perform in that manner on some other period where we already know what happened. So you might pick, well, I'm going to pick the 1st of January as our training date, the 1st of April as our evaluation date, and if I succeed in making a model that is predictive, I will then apply that as our scoring date to the 1st of October, to the current position, and I'll use that to drive my campaigns. So the output from behavioral modeling, just like a profile PWE model, is a score. That's the technique we're going to be using. Indeed, what we're creating is on-the-fly variables, these behavioral feature variables that will be used in your profile to create PWE scores that can then be used by all your users. So you can have multiple different behavioral modeling models in use that can be used by different teams or users around your organization to drive different purposes. But I guess the most common purpose would be that the scores are used to drive campaigns, either directly output from FastStats or through PeopleStage, used to create campaigns in a multi-channel, multi-wave environment. So as I said, the data model needs to have at least 2 tables, typically people or customers and their transactions, but there could be multiple different types of transactions. It's a real strength of the FastStats data model that you can pull together transactional data from multiple sources, link it to the one individual, and we can span all of that as we're detecting behaviors. And we will be looking at that one person and their multiple transactions, possibly of different types over time. And as I said earlier, that may include further detail. Each transaction may have further detail, and we can use that further detail. Notice that in both cases the time is from the transaction when it occurred. The product detail is within that, so we're lumping that basket together, for example, and saying all of this occurred on a particular day, but what was the makeup? Can we see the content of that basket and react to that as part of the behaviour? And as I said, 3 different dates. Here's an example. Across time, we use the data up to the initial point in time to train the model. We then use a different evaluation date to measure the model. And if all looks well, we will apply the coefficients, the PWE scores from the model to the current position, the now date, to apply the score to use for your campaigns. Actually, although I say it's now, you don't need to do it literally to the day. It might be best, for example, to choose a fixed date and use all the behaviours up to that date to make your model and apply that. So for Christmas campaigns this year, for your charity, for example, you might use data up to the end of November and then use that as your reference point and the reference data for scoring. So in summary, behavioural modelling provides a framework for analysts to create many ways to characterise customer and donor behaviour. The point here is that you could do much of this by hand. I'll show you how the techniques are constructed, but we're making it super quick and easy for you to create these behavioural features so you can work more effectively for your organization. The different features you create we call behavioral features, and you can create as many of these as you wish, and you can use a range of techniques to create the features. And in each case, you can measure the power of that behavioral feature in identifying your target group. And those features will be used for creating PWE models. Now, let's just see the different types of behavioral features. So the first one is frequency counts. So you can look across the number of records related to an individual, count up how many there are, and use bandings of that frequency count to determine whether that is something that helps you predict the behavior you're interested in. You can use date periods. So you could look at dates by day, by week, by month, by quarter, or by year to restrict which transactions are included prior to the training date or prior to the evaluation date, and finally prior to the scoring date, to see if the different windows on that data help you make predictive effect. You can use criteria on the transaction data. So you can look for the presence of data on the transaction. So in this case, looking for the purple highlighted rows, does this person have the presence of selected categories? And you can select them in a variety of ways, but do they have the presence of data in their transaction data? So their presence of categories in their transaction data. You can look at things like numeric functions. So looking back over the transactions, you could find the minimum, the maximum, the average, or the total from the transaction data that you're dealing with at that particular point in the feature. And one of the things you'll see as I demonstrate it, I hope, is that the effects are cumulative. So you can bring multiple of these techniques together to look at the behavior. So you could start with a frequency count across all the history of the transactions for an individual, and then restrict it to the transaction count in the last year, and then look at the average spend of the transactions in the last year for that individual. So you're building up the effect by bringing together these techniques in a variety of ways, and you can follow your train of thought through them. Next one is called combinations, and this allows us to look for particular categories. It's a variation of the criteria that I just spoke about. So in this case, I've got 3 selected categories and a number of unselected categories. And the first pattern we can look for is people who have none of the selected categories. They may have other unselected categories, but they've not got any of the ones we're interested in, or some of the selected categories where they may have one or more of them, and they may have others unselected categories, doesn't matter. Or we may ask them to have every one of the selected categories, and they still may have others that we don't care about, not interested in for this feature. Or we could say we want people who've only got the selected categories, or finally, and the point there is they have none other, and finally they have got exactly all of the selected categories, and again, no other categories. So 5 built-in patterns that make it easy for you to look across the data and find the values you're interested in. Finally, we have calculations built in that are designed for use over date periods. So we can look at the change in between 2 date periods. So in this case, the illustration that the second date period is bigger, higher count, for example. So was the change positive or negative between date period 1 and date period 2? And then second option is to look at the proportion. So, for example, the count in date period 1 as a proportion of the count in the prior date period, for example. So what's the ratio? And often where you have transaction histories of different lengths, looking at the proportions rather than the totals can help you determine the characteristics. So instead of just seeing the effect that someone's been a customer for a long time, they've made a lot of purchases, actually it's the proportion of their purchases that are high value or to a particular category that's interesting. Right, let's go and have a go. So I've already logged into FastStats, and the first thing I'm going to do is create my target group. Now, in this case, I'm selecting on people who've made bookings, and we've slightly extended our standard reference data in this case to include activities within those bookings. And I'm going to look for people who have undertaken some form of park run during their holiday, and I'm actually going to do that based on a travel date, and I'm going to say that I want the travel date to be in the next 3 months. So let's go for the next month and just edit that and say that we want the next 3 months. So we'll give this a name. At least we will if I can drag properly. Park run in next 3 months. And that's going to be our target group. The important point is I've put a date criteria in there because for this technique to operate, we need to have a date, and everything we do will be using dates automatically to adjust the point in time that we are looking at. So let's open our modeling environment. I'll give us a bit of space to look at that. Completely standard modeling environment, and I'm going to drag on our park run criteria as our analysis group, and you'll notice straight away that the system has added a base. That's the normal behavior of the modeling environment, but it's been extended so that we have a base, in this case, recognizing that we use the travel date in our analysis rule, and so we've automatically created a base rule with a date criteria. And you remember from my introduction that we need to set a date to measure or train by. So first of all, we're going to set a date for the training period, and I'm going to set it to the 1st of January 2020. We're going to look at the data up to that date. So actually all the data we're going to be using is from the end of 2019 and before. That's the date that we're going to use, and when we do so, you can see that the modeling environment has offered to add me the behavioral modeling dimensions, and tells me I can hide them again if I wish to. So let's agree to that. I'll say yes, please. but nothing appears to have changed. Well, actually, those columns have been added in here. This is the Dimensions tab. We'll be using it a lot during today. And you can see we have some new columns that have been added for us because the system has spotted that we've set a date on the modeling environment. But we can use this environment just the same as normal. So I could go and get two of the variables that are used widely in our demonstrations and our testing. Let's put income and occupation onto the modeling environment and just build that. And those of you who know the modeling environment will be familiar with this. It gives you a mini profile, if you like, and we can see for the income, which is highlighted, the income bands across the bottom, the percentages up the side. Green is the people who've done the activity I'm interested in, so they booked a parkrun in the 3 months after the training date, so during the first 3 months of this year. And our base is anybody who has a booking up to the beginning of that year. So we can see percentages for income, we can see the same for occupations, and for either of those or both of those, we can change this to show PWE. So you can see we're getting a negative PWE score for the underrepresented low income categories, and we're getting positive PWE score for the higher income, and the top two categories are not statistically significant, so they've been labelled in yellow. So that's all normal. And notice there's nothing appeared in the behavioural columns at all. But now let's add our first behavioural characteristic, our behavioural feature. And I'm going to generate our first on-the-fly aggregation, and I'm going to do it using the frequency or count of the bookings using the travel date. So the same date as I've referenced in my analysis. And you'll see that this appears just like a variable in the modeling environment dimensions tab, but actually if I right click on this one and choose to view a copy, you will see that it is an expression. And those of you who are familiar with these expressions might recognize that this is an on-the-fly aggregation. It's called count bookings before the training date. If we go click on that, we can see here's the on-the-fly dialog. It is a count of bookings looking at the frequency between the people and the bookings tables with a subselection, which if I view a copy of that, we can see has a date criteria of before today. Notice at this point it's referring to today, and today will be adjusted as we run each of these features based on the evaluation date that we've put into the modeling environment. That's the clever bit. And you'll see as we proceed now that it's going to warn us about that particular use. So let's just put one more on there just to help get us started. I'll also do the count of the web visits. So two different transaction tables. My data model down here has a variety of different tables in it. So I've picked the bookings and the web visits as our start point. We could use the insurance policies or anything else. And actually a good analyst would be exploring all of those. I only have an hour with you, so I'm just going to use these two to start with. So let's now build again, do that mini profile. And it's warned me that dimensions based on expressions, these are the bottom two, are only supported within the modeling environment and profiling tools, but not within decision tree or cluster. If you want to do this type of work with decision tree or cluster, you'll need to do it manually, and you'll need to create a virtual variable to hold that on the fly result from the expression. We may in time roll out this technique to this capability to the other techniques, but right now it's warning you it's only applying to those two. So the modeling environment has updated. We now have some data in the behavioral columns, so we can see that we've got a date period, in this case just looking before the training date. We've got the same measure, the PWE measure, and we can see that the number of bookings is not as predictive as the income, for example, and the number of web visits even less so. That's not proven at this stage to look like a useful predictive capability. And we can see that actually by sorting by the PWE column. We can see the top rank is the income, and we can see, for the bookings, for example, the count of bookings. If you've only got one booking before the training date, you are unlikely to book the park run in the subsequent 3 months. If you've got between 2 and 5 bookings, then actually there's some hope. If you've got many bookings, less so. And you can see the statistical significance in the colour. Web visit, well, very little discrimination if you've got 0 to 1. If you've got 2 or 5, then a little bit of value in there. So let's see how we can improve that, and we'll take the better of the two. We'll look at the count of the bookings, and we'll explore it by some of the other behavioural features. And the first one I'll do is date periods. I told you that this is going to use some standard date periods that we've built in, and so I can say I want to generate different units of date for this particular behavioral feature. You'll see what happens. Let's choose that. It's warning me that we are going to add 5 new behavioral features, and it's asking me what I would like to do with the one I started with. I can leave it there and still marked ready to be used in its own right. I can uncheck it so that it is not going to be used any further. I can delete it, or I can abandon this action, which would be the same as cancelling. So in this case, I'm going to leave it in place, and we'll see that we now have a further 5 items that have been added into the modelling environment for me. They're all based on the count of bookings, but now instead of being any time before the training date, they are 1 day, 1 week, 1 month, 1 quarter, and 1 year before. Let's just build that and see what happens. Takes a little bit more processing, doing the on-the-fly aggregations. And when we finish, we find that actually it has retained the sort on the PWE. So we still see this because I'd sorted the column descending. We still see the highest PWE score variable at the top, and it's no longer the income or the occupation. It is now the knowledge of the count of the number of bookings in the 1 year prior to the training date. Second, more predictive, is the number of bookings in 1 month and the number of bookings in 1 quarter. Now, I will warn you from the outset that these are clearly correlated characteristics. The numbers are related together. So as always, you need to be careful about double counting and think about the correlations between the behavioral features that you are creating. But we've learned something interesting already because we've seen that these have some predictive power. But do they? Those variables at the moment have been given PWE scores based on the different percentages, the green being the target group, the blue being our base, and detecting the differences. You can see in this 1 year before variable, we've created automatically some sort of sensible banding, and part of our objective at Apteco has been to make this as sensible and built in as possible. So those bandings seem to have shown differences between the analysis and the base group, and that's been wrapped up into nice positive PWE scores for where we are overrepresented. But we can do better than that. If I just spread this out a bit and now set an evaluation date, let's choose that not to be in January this year, but to be the 1st of April. So 3 months later, we're going to use that as a separate window on data, onto a different set of data. And the system has automatically introduced an additional column. This power column will show us the power of each of these individual features in isolation, as if we had made a model just with that one feature in it. And it will detect how well that variable can identify the target group on a new set of data. So we're not using a holdout sample, we're using a different set of data, and we're testing against that. And I can rebuild the modeling environment. You can see it evaluating multiple on-the-fly aggregations for us, and we now have a power for each of these variables, each in isolation, and I can sort these descending to see now, instead of the PWE view of which is most predictive, a tested view that is showing how well this has done on identifying a different set of data. So it's been trained on the data up to the 1st of January, but we're testing on data up to the 1st of April and looking for people who booked park run activity in the 3 months subsequent to that. In both cases, they're historic. In both cases, we're working with data that has already been recorded, but the intention is to prove how effective is this model so that we can learn to trust it and apply it to our new data. So we now have our breakdown for the 4 dates, and we can see that the count of 1 year is the most predictive, but we can see some down here that are really not very predictive at all. So the number of bookings before the date by just 1 day, the number of web visits, the bookings 1 week before. Well, we don't need to carry those around. We don't need to calculate them anymore. You clearly might choose to go and follow them, but they're as easy as that. Just press the delete key and they can go. So let's look at some other features. So we know the bookings from 1 year seem to show us some predictive power. Let's look now at the change over the 1 year period. So we're going to do a calculation here, and we're going to look at a change in value from the previous date period. Now you can see our user interface has lots of options in it, some of which are grayed out, some of which are available, depending on what you have clicked on. We're validating what you can do with each of the features that you have got. So let's now look at the change from the previous period. Again, we're told that we're going to add 1 new feature. Do I want to leave the existing? And from now on, I'm generally going to say, yes, that's fine. I'm leaving the existing there. So we're now looking at the change in count from the year prior to our training date to the period 2 years prior to our training date, automatically building that period for you. And we can see, again, by default, it's sorted by the last column I chose, which is the power. And actually, this is the second most powerful. So now we've opened up the window a bit. We're looking across 2 periods rather than just the 1 year period. Let's try something else. Let's look at, and I'll illustrate a slightly different technique. We'll use the count of bookings any time before the training period and the count of bookings in the 1 year. And I'm going to look not just at the count, but we're going to look at the value. So we're going to look at the numeric functions. And again, we've built in many of these for you. You can choose just to do the summation, but I'm going to do all the different numeric functions based on the cost of the booking. This is showing us all the appropriate numeric variables in all the appropriate tables below the resolve table that we've used for the modeling environment, derived in this case from the initial analysis rule, which is the number of people who booked a park run. So I'm going to use all the numeric functions. It's going to tell me I'm adding 8, min, max, average and total, for 2 different time periods. And there they all are at the bottom. You'll notice there is an ID column here at the left-hand side that shows the ID of each behavioral feature that you add. You can always sort by any of these to get back to that. But let's just build those, and we'll see whether they add any value. Quite a lot of computing going on here. I'm actually running this locally on my laptop, but it'll work just as well on a server, which can obviously handle more breadth. And oh dear, we don't seem to have done anything useful at all. We can see those 8 have remained at the bottom and have got very low PWEs, or nil PWE, and very low power. Why so? Well, one to be aware of is that because we derived this numeric function from a count, and I told you at the beginning the count was given a reasonable basis, you can see between 0 and 50. Actually, it by default has used the same bandings for this cost. And so that doesn't feel so appropriate, does it? The costs are higher than the count. So let's put a different banding in, and we can do that really easily for all 8 in one go by choosing simple banding. There's the default that was in there. I'll do something quick to type. Let's do something like that. Fastsass will sort out the overlaps for me, fortunately. And we can try again and see if our manually created banding is better than, well, the rather inappropriate default banding that we had in this case. And we can now see that the totals, well, they've crept somewhere up there. The total in the 1 year before has given us some predictive, some PWE and some predictive power, but most of the rest of them are still pretty minimal usage. And you can see, I don't know if I highlighted, because we picked 2 variables initially, we have some that are doing the whole history before the training date, any booking at any time, and some are doing just the 1 year before. And we've got some predictive power. But this is the point. You can analyze and explore ever so quickly and easily, and then you can delete the ones that you find are of no consequence. Just keep the ones that are worthwhile. Right, I'll just keep an eye on the time. Let's do a couple more. So let's go look at the count of all bookings in any period. There you go, that one before the training date. And I'm going to use some criteria. So another technique, I'm going to generate criteria using a variable from the bookings table, and I'm going to look at the continents. These are all the categorical variables from the bookings or transaction data. I'm going to look at the continents, and the modeling environment and the behavioral modeling feature can pull up all of that. I can select it all with one click. I can take away the unclassified, and I can choose to create multiple features, one for each selected category, or I can do one with all of them together. I'll show you some variations of this in a minute. So let's just OK that. We're going to add 5 new features. Here they are: Australia, Europe, America, Asia. We're trying to make it easy for you to see what you've selected on for which period with what type of function. And as you've seen, I can build this ever so easily. And we will get a new ranking, again, ranked on the power, and the Americas and Europe destinations, the counts of those at any time before the training date seem to be predictive. But again, let me warn you, look at the characteristics we've got here. We have a count of the 1 year period, a count ever of America, and a count ever of trips to Europe. Those sound like they're similar pieces of data, don't they? They are correlated. And so as an analyst, you should always be looking at what are the characteristics, how can you detect it? And actually, you may know we have an association matrix in the modeling environment. We don't yet support that for these on-the-fly aggregations, but that's something that we will work on, so we can help identify for you where you've got correlations. Incidentally, note this: you can see that the Europe variable is showing negative PWE score. So if you've been to European destinations once or between 2 and 5 times, you're less likely to book to take part in the park run, whereas if you've been to America, you are more likely. Right, let's do something just a bit more sophisticated. If we look at this count of America, we can choose, instead of just doing a simple count, we can look at the proportion. So we can look at how many American bookings each individual had as a proportion of all of their bookings. So I'm going to choose a right click, I'm going to choose a calculate, and I'm going to choose calculate relative to total for the variable, the continent. So this is looking at a breakdown. Rather than saying someone has got 8 bookings, for example, it would be looking to say what proportion of their bookings have they got to America. We're only adding one feature. Let's see that down here. And if we build that, you will see that it's actually slightly more powerful than the count of the number of bookings. Incidentally, this modeling environment is caching the work that we're doing. So you see that build was much quicker than the previous one. I'd only added one new feature, and we're using clever techniques in Apteco's engine to keep that cached for you. So in this case, I could say, well, I'm going to remove the simple count of the number of visits to America because I've now got a more sophisticated count. This is showing here a proportion. So we can see if it's up to 20%, up to 50%, up to 80%, or 100% of your bookings, for example. So this is indicating if you've only been to America, you have a strong indication for booking the park run. And so I can choose what variant to use. In this case, either by unticking the use indicator or by just deleting the row I use the delete key. You could right click, you can remove it. Right, let's just do a new capability, and this is the combinations. So what I'm running you through is a series of techniques. You don't need to use all of them, but I'm trying to give you some idea of what you can do. So let's look at people who have got bookings, and this time I'm going to create criteria generated using a new combination. This is a rather deep menu, isn't it? Using a combination of activities, and I'm going to just use the summary activity type. And you might remember we have the choice of none, some, every, only, or exactly. So I'm going to choose two of these, the sports and the tour types, and I'm going to use the default in this case, which is to pick some of those. So let's give this a custom name, and we'll call it Sporty Tourists. And we've added a new measure. So this is looking at the combination of the details in the activities related to each booking. And we can run that, and there it goes. We find that's actually the most predictive characteristic that we've seen so far. So by delving down into the detail of the bookings, by looking at the activities that have been previously booked, we can see if on 1 or 2 to 5 previous occasions you have booked a sporty tourist activity, guess what? You're more likely to do it again. So let's get rid of some of the low-scoring, unpredictive items. So I'll take some of those out. That'll do. Doesn't really matter. I'm just really choosing it so it's easy for you to see on the screen, because what we're now going to do, having explored these behavioral features, we are going to create a profile, and the modeling environment can launch each of the tools, profile, decision tree, and clustering, well, profile and decision tree and model report. Remember, this only works with profiling. And we can run the profile just as normal, except this profile is warning us that we're going to use the 1st of January. That's been carried over from the modeling environment. Because we're doing behavioral modeling, it's going to use that rather than the current date. And remember, my target group and my base group both have that date rule in. And here's our standard profile. You can see the standard shape and characteristics of that. And if I sort this descending, we can see that almost all of the behavioral characteristics, the behavioral features that we've created, almost all of them have a higher mean PWE than the income and occupation variables that we dropped in there to start with. The characteristics we found from the transaction history are doing a better job of predicting the activity that we're interested in, which is booking a park run. So that's looking hopeful. Let's make a score from that. So I'm going to create a PWE model. And for simplicity for today, but this is not the most powerful way of presenting the data, which would either be quantiles or actual values. For simplicity today, I'm going to use equal ranges, each 1 point wide. And I'm going to build this using not today's date, but I'm going to go and use the evaluation date that we set before. Could be any date, but I'm just going to go back to the evaluation date so that we can see what the power measure has been reporting to us. We can see it with the combined effect now, not just of one variable or each variable in isolation, but looking at all of them combined. We don't need a subselection. I don't really mind where I put the variable. I'm not writing any notes, but I will put a evaluation model park run, and this is actually 1st of April. And let's go. So same sort of process as usual, working through applying the PWE coefficients for each of those variables to every record on the database, except now we get a second stage. This modelling score will need to refresh using the scoring date. And that was the date I just put in, 1st of April. Might take some moments. So press OK. We'll see the system is now doing that. The wizard is waiting for the system to update that variable with the point in time that we asked it for. It scored all 1 million people. Let's have a look at them. And hey presto, we have a PWE model. Many of you will have seen score ranges looking something like this. The worst possible fit is -11. There's nobody that bad on the database. The best possible is 21 points. There's no one that good on the database. But in between, we've got a nice looking distribution based on all of the characteristics that we have in this profile. And let's just see that now, because that will have appeared automatically on our results tab. And if I choose to look at just this one, I don't need the other one, let's just launch that into the model report. In fact, sorry, I chose the wrong one. And we do that. Let's just launch that into the model report. And this is our evaluation model for parkrun. And again, it's saying that it has carried through the scoring date we use. That's attached to that variable behind the scenes. It's going to use that. And here's all the scores. We saw nobody was in 20 to 21, but we've got a couple of people in the 19 to 20 category who've been found to meet our target. Rather than look at the numbers, let's look at the response chart. And boom, there we go. That's a nice looking model, isn't it? We've got a big lift above the random line. With all the caveats that I said earlier, I've used several correlated variables there, so we've got to be careful about overcounting. But we've shown how we can build a model using behavioural features that is stronger than the geodemographic data that we had on these individuals to start with. So that's a lovely looking model, and I can do lots of work to use it and test it and evaluate it in different ways. But actually, I'm going to go back to my profile, and I'm now going to say, I trust this model. I've seen the evaluation process in the modeling environment. I've seen it now as a combined effect, as a PWE model with multiple variables contributing to a score that looks like it gives a significant lift above a random arbitrary selection. So let's now apply it for real. And so we'll make another model. And again, for today's purposes, I'll just do simple 1-point banding. But the point is, we're doing that, well, maybe not up to today, because we've actually only got data from last night. So let's do up to the 1st of October. We're going to take the model that we've built. We've tested it on the first, we've built it on data up to the 1st of January. We've tested it on data up to the 1st of April. We're now going to apply it to the 1st of October, and all the same, this is our campaign behavioural modelling park run PWE, and off we go. And in just the same amount of time, we're now using the latest information we have on all of the customers that we're selling to in our fictitious travel business, and we've made a model in moments in front of you on 1 million people, and I can open that up and we can see the same sort of distribution, different numbers, actually the same theoretical highest score, of course, because it's using the same coefficients and therefore the same lowest possible score, but the distribution is different. The numbers in each of the categories is different because it's been built on the 1st of October data rather than the 1st of April data. And you know what? I can choose it from here, or I can go use a model report. I can go select on that, target it, and drop that into an export, or use it in people stage to target those individuals. So let's just drop back to the slides, and hopefully Mel is able to share the feedback poll for you. So can you just give us a guidance? Do you think that's interesting? Do you use transactional data already or not? Is it something that's applicable, or are you just so confused you don't know what to say? And Mel will judge that for us. Cool. That looks nice. So that's yeah, some people doing it already. Hopefully you can see that we've made that a much more efficient process. It's super easy now to create behavioral characteristics, and good. Lots of people saying you're interested. So Mel, perhaps you can just go on to the second poll. We're interested in what help you need to make use of this sort of facility. We've recorded today's session. We'll share that. You've got the handouts, but what else would help you? Do you want videos? Do you want training courses? Do you want documentation? I should have put an option on there for everything, shouldn't I? But yes, what will help you most, I suppose, is what we're asking for. And Mel, when you're ready, you can share that. Okay, cool. That looks useful. Thank you very much. Right, so I think if Mel closes that poll, I'll continue with the sharing. All right, we have another poll. Looking forward to using the new features or not. And when people have answered that, well, fortunately, nobody's asked for their hour back, so I'll count that as a success. And yes, that looks positive. Thank you very much for your feedback. Right, let's just give you a little idea of what is coming next. So here's some transactional data for 3 customers spread across a timeline, lots of different types of activities, some of which we've determined as relevant communications, some other types of communications. There's particular events we're interested in with the big purple blob, and 2 of our individuals have done that. There's lots of other transaction data in there. How are we going to learn about this data? How can we use it? Well, the sort of base we might use is anyone who's received a relevant marketing communication. And then the analysis might be people who performed an event after the point in time of that communication. So we've got a slightly different challenge, haven't we? It's a movable communication date, and people take action at a movable time relative to that. So what we're working on now, my colleague Ray Kirk, who's actually on the call for questions later, is working on the mechanism to detect the relevant communication and set that as a reference point, and then look for the group who have performed the activity that we're interested in, so in this case the purple blob, and compare those people with the people who did not take the activity that we're interested in. But you can see those 3 windows, if you like, the squares that we've put on there, are at different time periods. What Ray has been working on is the ability to do this, to align them so that we can see those individuals relative to the date of the communication, and then use that, identifying those who undertook the activity that we're interested in, and look at the behaviours in the same way as I've been doing today with fixed dates. Effectively, we will be referring to relative dates within the transaction history. We're also introducing the ability to look at recency. So instead of just looking at the total within 1 year, we can look, for example, at how long is it since your last communication or since your last purchase. And both of those capabilities will be in the Q4 release. So just to round up, takeaways. I think we've shown you how you can uncover multiple different types of patterns across multiple channels and transaction types. We've tried to show you some practical steps. You've got a handout that gives you real detail of how to do this. Go, if you can, download that, take a moment to read it, and hopefully you can see that you can now use previous behavior to predict future behavior of your customers. If you need support in using this new technique in the Apteco software, do of course talk to your partner, talk to Apteco, our support team, consultancy team. Will be delighted to help. And please, everybody, stay safe. If the most powerful man in the Western world can get COVID-19, I'm afraid it can happen to any of us. So at Apteco, we're taking proper care. I hope you can too, in whatever situation you're working. Thank you very much. That's the end of the webinar.